Time accuracy in Windows Server 2016 has been improved. Let's discuss the improvements and learn how to achieve the best accuracy in your environment. Under the right conditions, you can achieve 1 millisecond accuracy with regard to UTC, which can help you meet regulatory requirements. And the best part is that you get this accuracy in your domain with minimal effort. If your PDC is accurate time and your network is up to the task, your domain clients receive accurate time automatically as a member of the domain. To see the improvement, the Windows 2012 R2 results for a PDC are overlaid on the chart, which shows the offset from UTC over time. You can see how much better the accuracy is with Windows Server 2016, which stays in the desired accuracy range. Provided your network and environment are sufficient, the 1 millisecond accuracy on the PDC will propagate throughout your domain to Windows 2016 servers and Windows 10 anniversary clients. But before we go any further, let's get some background to help us understand how to implement accurate time in your environment. A basic understanding of NTP, the Network Time Protocol, is useful when designing and implementing a Windows domain which requires accurate time. NTP sends a request on a regular basis to a time source. The source returns an NTP response and 4 times are measured. A formula is used to determine the time offset between the clocks of the client and the source machine. By the way, one improvement we made in this regard was to increase the frequency of NTP requests in Windows Server 2016, which helps us achieve higher accuracy and stability. A main consideration with NTP is that it assumes the round trip is symmetrical and that the latency for the request and responses are the same. If you have a network with a lot of network hops in between, your chances of achieving accurate time decreases. Your network architecture and load play a big role in getting accurate time. Based on time offset information we derived from the NTP packets, Windows uses algorithms to determine how to correct the clock. It considers each time offset, but algorithmically processes the raw data to control network jitter and noise that is persistent and uncontrollable. But Windows doesn't change the computer's clock time directly, because jumps in time, especially backwards, could cause issues. For instance, a timed certificate could be used twice if the clock was set backwards in time. Instead, Windows Time Service adjusts the clock frequency up or down in order to approach the correct time, like the local clock is catching up with the UTC time below. This is called conditioning, or disciplining the clock. Let's quickly review how time is synchronized in a Windows domain architecture. Clients are automatically configured to synchronize with another machine in your domain, usually a DC. It discovers an appropriate time source by using the domain relationships and algorithms to optimize the hierarchy so that time synchronizes efficiently. MSNTP, a secure network protocol, keeps each domain member in sync with each other. The root of your domain is the PDC, which is the default master time source, but another DC can assume this role. At some point, your domain needs to refer to a highly accurate Stratum 0 clock, for instance, GPS hardware or a time appliance. A stable and accurate time source, like a GPS, PCIe card, or a time appliance, is critical for accurate time in your Windows domain. Any instability in the root source time gets amplified at each stage, so you won't get 1 millisecond accuracy downstream if your source clock isn't extremely accurate. Windows Server 2016 and the Hyper-V TimeSync service has also been dramatically improved in order to deliver accurate time to Windows guests. Linux guests can also take advantage using changes we've submitted. Before Server 2016, the TimeSync service would communicate time synchronization information using request and response messages similar to NTP. However, interrupts can disrupt the symmetrical nature of these messages, and as we pointed out before, asymmetry affects accuracy. The improvement removes the round trip, so latency is not an issue. This change lets us significantly improve the time accuracy for Windows Server 2016 and Windows 10 anniversary guests, as well as Linux with the appropriate distribution. When we discussed domain scenarios before Windows Server 2016, we recommended that you disabled the Hyper-V TimeSync service, which forces the virtualized DCs to communicate via NTP. This ensured that the whole domain would be on the same time, even if it wasn't exactly accurate relative to UTC. But with Server 2016 and Hyper-V, this is no longer required for guest VMs that also have the TimeSync service update. This is true for Windows 10 Anniversary Release as well as Server 2016. With a properly designed domain architecture and an accurate, stable time source, all Windows 2016 servers, virtualized or otherwise, will be in tight sync with UTC-based time source clock. With all this in mind, let's discuss the specific improvements we made in Server 2016 which let us reach our goal of 1 millisecond accuracy with regards to UTC. First, the general improvement was to the algorithms which take clock offset data from NTP, filters out the noise in order to correctly determine the offset. We also increased the depolling frequency and clock updates so that it references the source clock more often and the clock is disciplined more frequently. Finally, we added perfmon counters in order to allow you to test, baseline, and monitor your clock accuracy. Monitoring, for instance, could be achieved by creating a system center alert to signal you when your accuracy is outside a certain range. As we just mentioned, virtual machine accuracy was an issue in the past because the TimeSync service was prone to latency issues. By consolidating the synchronization information, we removed the latency issue completely. Now, your guest can be within 90 microseconds with regards to the host, even with a load. Additionally, we supply a more transparent stratum to guest VMs. Previously, the stratum was fixed, so guests might assume the host was the most accurate when that wasn't the case. Now, the stratum is passed transparently to the guest based on the host's real stratum, which it derives from its source. Based on how time synchronization works with Windows, we can derive some simple recommendations. One important point is that you need a stable and accurate time source. And the more network hops between the client and the time source, the less accurate time will be. That means you should have an accurate time source like GPS-based appliance in your data centers. If you have remote sites, you should set up an accurate time source locally and denote that in your domain as a good time server, which forces local clients to access it instead of the remote DC. And since accurate time is dependent on your network architecture, you will need to test your environment to validate your accuracy requirements. Each environment is different, and even the machine's clock hardware and firmware revisions can affect your accuracy. This is where those new performance counters can really help you out. Time accuracy is the backbone for many important transaction-based activities. Upcoming regulatory requirements require 1 millisecond accuracy with regards to UTC. Blockchain, the payment industry, encryption, distributed SQL transactions all require accurate and synchronized time. Manufacturing, power grids, and healthcare are other areas that stable and accurate timestamps are required in order to assure proper sequencing and monitoring. With Windows Server 2016 and a little care, you can easily distribute accurate time throughout your domain for any of these time-critical roles. If you need more detailed information about these time-related improvements, including measurements and best practices, it can be found on TechNet or aka.ms/WS2016 time. Thanks for watching.